over the last few lectures, what we have seen is we have seen about the power angle curve and the derivation for power angle. So again, there is a whatever derivation we have done, and we also found out how to draw equivalent approx circuit for synchronous generator. So these are some of the things which was found by me, so derived in the previous lectures to be approx. So what we found out was if you consider the synchronous machine, it's possible to have two kinds of rotor construction mainly. One is the round rotor and the other is the salient pole rotor. So there is a difference between the two lies in the fact that just drawing an approx diagram to show if there's considering a phase AA dash, and these are the two sides of the winding of a phase, and if you are having a rotor, then a round rotor would have the field windings mounted on a rotor in a distributed form. So this would be a distributed rotor winding, while in case of a salient pole, it's possible to have some kind of a construction like this where south and the north pole will be there, and just drawing a approx diagram, and the stator again will, if you are saying for a phase, it could be having a distributed stator winding, while the rotor is a salient pole, and here considering for two poles, one north and one south. So what will happen, this will have something like a direct axis which can be shown by D and a quadrature axis at 90 degree to that. So there will be two reactants, one is XD and XQ. So in the previous lectures we found out the power equation and power angle equation for both these cases. So again, in this case, in both the cases in which the derivation happened, was considering the resistance of the armature was very less than the synchronous reactance. So this was neglected and the equation was found. So in the case where the resistor is considered, so how will it look like? So what was found out was in the previous lecture was it was possible to give the power output per phase is equal to Eg into Va divided by Xs into sine delta, where delta is equal to my power angle, and this was the case for a round rotor machine when my Ra was less than Xs. So this was a specific case for a round rotor machine, and it was found that we found out the power angle curve based on this. So Again, the same equation was found out for a salient pole machine, which came out to be power output per phase was equal to Eg into Va divided by Xd of sine of delta plus Va squared divided by 2 into 1 upon Xq minus 1 upon Xa of sine of 2 delta. This was for a salient pole machine where my Ra was neglected. It was less than Xd and Xq. So again, considering what are the different parameters here, the power output per phase is given by Pd, and Eg is equal to my EMF generated per phase, and delta is equal to my power angle, and Va is equal to my voltage out per phase, and Xq and Xd are direct axis and quadrature axis reactance, and my Ra was equal to my resistance of armature for phase A. So this was a two equation. If I say this was a equation 1 and this was a equation 2, so based on this two equations, in both these equations my Ra was neglected. So I will show how now, based first considering for the salient pole, then discussing on the P output, the behavior and how to find the power angle delta in cases where you are considering your resistance. So again, just taking an approximate diagram. So just taking an approx diagram, approx illustration figure. So this is not up to scale, and just to show. So if you are saying that this is what is my stator, and if I'm having the south and the north poles, and this is a salient pole construction, so you can see there is my direct axis, which is this, and my quadrature axis at 90°. So this is my Xq and this is my Xd reactance. So based on this, it is, and the circuit diagram or the circuit model, it is possible to draw the phasor diagram. So if I draw the phasor diagram considering my Eg as a reference, so it's possible to draw considering my Eg as a reference. So I don't know where my Eg exactly lies, but taking an angle delta from Eg, what is my power angle lies, what is my Ia, and at a lagging power factor phi. So considering the case for a lagging power factor and a generating machine, so this is my Va which lies here. So this is my power factor angle, and if I'm saying delta plus phi is equal to what is my alpha, and so at 90 degrees this IA can be revolved into two components separated by 90 degrees. One is the ID and the other is the IQ, and if IARA can be shown as your resistance, and the components both in, so this will have two components. One will be at 90 degrees. So based on this you will be having a graph like something like this, which is for IAXD and IAXQ. So if I'm drawing a perpendicular component or the IDXD component, and what will be this is my IQXQ, because it will be at an angle, making an angle like this. So this is what is my, or this component is what is my IAXA, and this is what is my IDXD. So this is what is my alpha here, and so if you are resolving this, your VA into two perpendicular components, one would lie something like in this way. So if you are dropping your alpha, it would drop somewhere here, VA alpha, and it would drop somewhere here for the other component. So if you are drawing this, constructing a right angle from here, this being 90 degree, and if you are considering your VA from here, so this will form a triangle, if you can say it by OCB, and so this is a triangle. So based on this, now you are considering your R days. So based on this, your task is to find your delta or your power angle equation considering delta. So after getting to this point, it's possible to see from this diagram that my ID is equal to IA sin alpha and IQ is equal to IA cos alpha. That is, your ID is equal to whatever is your cos alpha, because you are projecting it here and you are projecting it here. So that's how you are getting these two equations. So based on any of the unknowns, it's possible to find out your alpha, and if you know your ID and your IA, then you can find out easily your delta here. If in that case, if you don't know, then the next is that the tan of alpha, the tan of the alpha in this case, which is alpha, is this, and if you consider this as a right angle triangle in this way, if you consider this as a right angle triangle, which is O, C and B, and this is my alpha, then my tan of alpha will be equal to OB divided by CB. So my, or just saying that it would be CB divided by OC. So tan of alpha would be CB divided by OC in that case. So if you want to find your CB in this case, your CB will be this component plus this component. So if you see this component, it would be equal to what is your, if you are projecting it here, if you are projecting it from here, then this would have to coincide with what is your IA here. So if you are drawing it to scale, which I will do for all the graphs when I will get the time and will publish a video by showing all the graphs in scale, and then I will update that in the description which you can find. But if you are projecting it on top from here, so whatever is this component here, what you will get, that will be given by something like equal to VA of sine of phi plus IA of into XQ. So this is what is my CB. So my CB is this part here. So this is my VA sine phi, and this is got by projecting it here. Plus of, so when I am projecting it here, I am considering this to be my reference, and considering this, if I am projecting my phi angle with phi onto this axis, which will give me a vector here, which is VA sine phi, and when I am taking this vector into scale, considering it like this and moving this amount here, so it will be VA sine phi here and IA XQ, which is this part. So divided by what is my VA of cos phi, which is the projection onto here, onto this, which is my reference, and plus IA. So this is what will give me my tan alpha, and my tan alpha is equal to tan of phi plus delta. So again, if you know your phi, then it is possible to calculate your delta from this equation. So this is how you can find your delta if you know, based on or by considering the resistance Ra. So this was for a salient pole machine. Again, some of the other consideration from this is that your V of sine of delta is equal to IQ into XQ. So VA of sine of delta is equal to IQ XQ, and ID is equal to IA tan alpha, which has been already found. So again, this is how you can find your delta or power angle based on this. So it's possible to simplify this equation and get a more general equation, but I will not go into detail, because if you know this, it's possible to find out the other equation. And since if you have got a problem in which you are to consider the resistance RA also, then you can solve it by using this phasor diagram or using this equation which is here based on this phasor diagram again. So it's possible to find out your unknowns based on your details. And if you are neglecting the RA, so already I have prepared a video of the derivation previously, so which you can find in the playlist for the power angle for the salient pole generator. So again, that was for the salient pole. And if you are considering the case for a round rotor synchronous generator, if you want to find the power angle delta in the case where you are considering the RA is considered, so again that can be found out by drawing the phasor diagram. So to draw the phasor diagram, I am taking the approximate equivalent circuit into consideration. So which I have already discussed, and if I want to again consider that to show it in simplicity, it will have two components which can be shown like this. So if this is my VA voltage per phase which is available at the terminals, and this is my XAR, and this is my RA, and this is my XA, and this is my EG. So based on this, it's possible to find out what is if a current is IA. So based on this, it is possible to draw the phasor diagram. So I just want to draw that, it will be. So I am drawing the phasor diagram by taking the IA as a reference. So if I am taking the IA as a reference, and then I am having a lagging power factor, so it's possible to show my VA this way, and this is my IARA, and making a 90 degree will be IAXA. So there is no IQ or ID is not present here, because this is a round rotor machine, and it's possible to join this, and it's possible to say that this is my EG and this is my VA. So this is my IA into ZS. So it's essentially possible to say that my EG is equal to VA, or EG vector is equal to VA vector plus my IA into ZS vector, which is a synchronous. ZS is equal to Ra plus J of xs. So if this is my angle delta and this is my angle phi, which is my power factor angle, and this is my power angle. So based on this simple case, it's possible to find out my delta as Eg of cos of phi plus delta will be equal to Va of cos phi plus Ia Ra. So based on this equation, it's possible to find my delta. So this is how you can find your power angle in case where you are considering your Ra, or if you are going for detailed derivation, then it's possible to find out your power angle by considering that your power is equal to, or power delivered for phase A is equal to VA IA, so which is equal to VA into your Ia, which is equal to VA minus EG divided by ZS. So when you are considering this in terms of angles, then this will be your VA is making an angle of phi, and your VA making an angle of phi degree minus EG making an angle of phi plus delta, and divided by what is your ZS making an angle of theta. So this ZS is making an angle of theta, so it's possible to get this in terms of angle of delta if you are going to solve this equation. So it's possible to get your power equation in form of delta. The other way to get it is to consider this as alpha, as a, or phi plus delta is equal to alpha. So your Eg cos of alpha will be equal to Va cos phi plus Ia Ra, and you can find your cos alpha is equal to Va cos phi plus Ia of Ra divided by what is Eg. So based on this, again it's possible to find out if you are solving for this, or based on solving for this equation, it's possible to find out in terms of three parameters. One is your phi, one is your delta, which is your power factor and the power angle, and your theta, which is equal to your impedance angle. So again, that's one derivation which you can do, or which you can refer in your reference books if you are looking. So if you have a problem based on considering the resistance to find out, then it's possible to find out it from this phasor diagram, or it's possible to derive the equations. Use one of these two equations which is possible to get from this phasor diagram. Also you can directly solve it from this phasor diagram, which should give your delta, or what that will give you is your uh, delta plus alpha, or if you're considering for this, only for this, it will give you a delta. So the EG will be making an angle of delta. If you are considering only for this phasor diagram, where you're considering this as your reference axis, so if you're considering this as your reference axis, and this is the delta which is making it with the x axis, so in that case when you're solving for this EG, it will resolve into x plus jy. If this is your x axis and this is your y axis, then your EG can be found out as x plus jy, and your tan inverse of y by x will give you what is your delta in that case. So that's the other way to find your delta, or you can use either of these three ways. To find your delta. So again, considering the equation for EG, I have already solved an example which you can find in the description or the playlist.